So the reality is we've done addition and subtraction. Now we're going to talk about the fact that if you take one side of an equation and multiply the other side, you have to multiply the other side by the same number. Well, we use scales to talk about this. So here we have, just imagine the red being an apple. Okay, we have one apple on each. Well, if we multiply that by 2 on one side, we have to multiply by 2 on the other to get 2 apples on each side. What would the algebraic expression be for that? Start off with 1 apple on each side. What would you do from there?
A times 2 equals A
Look.
times 2, or
Okay, yeah, you could do 2a, 2a, but we knew there was 1 apple, right? So you could just do 2 times 1 equals 2 times 1, right? Otherwise, in other words, if you tried to put, let's say you multiplied the right by 3, what would happen to the scale? It tipped to the right, so you can only multiply that by 2. Let's say we might start with 2 apples, and we want to multiply those 2 apples by 3. So if I multiply the left by 3, I would have how many apples? 6. In order for the scale to balance, I have to multiply the right side by 3. I have to put 3 times as many apples on the right. What would that expression look like? Whoops. Yeah, okay. 2 times 3. You could write 3 times 2 or just 2 times 3 again. Either way. Basically, you're taking 2 apples and multiplying them by 3. All right, going back to the baskets of apples. So we have 2 baskets on each side, 6 total apples. If we multiply that by 3, we'd have how many apples on the left?
6.
More than 6. 6 baskets. We had 18, right? Right, so you'd have to multiply that by the same on the other side. What would the expression be for that? This one's a little bit more complicated. We started out with 6. We had 2 times 3 on each side, right? Basically 2 baskets of 3 apples each. And we took each of those and multiplied that by 3.
You could put 2 times 3 equals 18 equals 3 times 2 equals 18.
Okay.
And then
Yeah.
put like a
But you're right.
3 times 3 times 2.
Okay. So either way, we multiplied our starting number of baskets by 3. Otherwise, if we multiplied it by 4, for example, and we added, let's say, 2 more baskets up here, you guys get the idea, it would start to weigh it down. So properties of equality work for division, multiplication. The X stands for, okay, something else. 6 orange shirts, okay? If you start with 6 times the number of orange shirts in a box, we don't know how many that is, so we call it X. We multiply that by 3 on this side, have to also multiply it by 3 on the other. It's only fair, right? In other words, you would get 18x equals 18x. Remember, the middle of the scale can be thought of as the equal sign. Okay, let's say we have 2x plus 7. 2x plus 7 on this side. All right, if we take this side and multiply, let's do a fraction this time, times 1/2. Okay, no matter what this number is, this is now going to weigh half as much as it did, right? So in order to balance the scale, we'd have to multiply this side by half so that they would be equal. It makes sense. It's like adding and subtracting. Let's do some examples. One thing you're going to see in math a lot is something like this. 2x equals 8. And if I multiply this side by 1/2, what would I have to multiply this by? 1/2. This is actually what we'll be doing next week. The way this would solve out, not that you have to know it right now though, 1/2 times 2 would cancel and you would get x equals 4. So right off the bat, there's an application to multiplicative property of equality. As long as you multiply by the same number on both sides, they stay equal, just like that scale, and you're able to solve for x. Number 2, let's say we have 3x plus 6. Here's another kind of practical one, and that is equal to, actually, no, let's do 1/3. This is kind of do the opposite. So 1/3 plus 6 equals, let's say, -2. Again, one thing we would do to solve this is we would multiply this side by 3 to cancel the 1/3. But in order to do that, we'd have to multiply this side by what? 3. And we're not going to solve that one out, but you get the point. Let's do another one. Okay, x times 7 equals what times 7? X. So we multiplied both sides by the same number. I think you guys are good on this one, right?
Yeah.
Let's do one with e and pi, just because e pi equals e what? All right, so this one doesn't have a multiplication sign. How do you know they're being multiplied? Because they're right next to each other, correct?
Well,
Alright.
I mean, pi already has the I in
Right, you can't spell pi without e in the I.
it.
Yep, that's right. Okay.